Hi again. In this lecture we will look at how the second requirement on the operating range of an electric drive, the maximum speed, will influence the design of the machine and its cost. The speed of an electric machine can often be increased with no changes to the design of the machine except better bearings. The centrifugal forces on the rotor of course increases with speed. At first they have no significant effect, but eventually they become strong enough that the rotor design calls for expensive materials and advanced manufacturing methods. Since the centrifugal forces increase with speed squared, the problem with the rotor strength makes it costly to achieve electric machine speeds over certain limits. For many EV motors, the typical speed limit is in the order of 10 to 15,000 RPM. Exactly at what speed the limit occurs depends on the radius of the machine, so smaller machines can have a higher speed limit than big ones. At speeds where the centrifugal forces are low, there is almost no additional cost for increasing the speed limit. At higher speeds, the rotor design has to be changed to allow for higher forces, and then the cost starts to increase significantly. This machine has a top speed of 5,000 RPM. Increasing the maximum speed does not influence the maximum torque of the machine. Here the top speed is 7,500 RPM, here 10,000 and 12,500. Now the speed is so high that a further increase would increase the cost of the electric machine in a significant way. The fact that the cost of the machine strongly depends on the required torque and is almost independent of speed makes a strong argument for using electric machines with a high speed limit. To prove the point, we can for example look at mechanical power, which is the product of shaft speed and torque. Since there is almost no cost for increasing the speed, an increase is a way to increase power at almost no cost for the electric machine. Of course, some additional cost for the transmission may have to be included when determining which is the optimal speed limit. The fact remains that it is cost-effective to use as high speed limit as possible until some speed-dependent machine design factor kicks in and significantly drives cost. Such factor is the mechanical strength of the rotor. There is another advantage of high-speed electric machines, and that is that they typically have high efficiencies. At a constant torque, the losses of the machine typically increase less than linearly with the speed, while the power produced increase linearly. So a machine with higher speed generally have higher efficiency than a similar type of machine for lower speed. This lecture has explained why it is often beneficial to use high speed of the electric drive. A high speed provides high power and high efficiency of the electric machine at a low cost. One factor limiting the speed is the strength of the rotor in the electric machine.